discharged and hydrogen gas was liberated. At the anode, hydroxide ion is discharged, and for the discharge of hydroxide ion, oxygen gas will be part of the product, and since oxygen is diatomic, it means that 4 moles of hydroxide ion must be required to give 2 moles of water plus oxygen, where this oxygen gas will, be liberated. Our interest here to the question number 2 is this, because this is what gives the oxygen gas in this system, and we require 4 moles of hydroxide ion to give 1 mole of oxygen gas, which is diatomic. So that means, bringing this equation down, you have this. By this, we have 4 moles. So for every 4 electron, there will be 4 moles. And for every 4 moles, there will be 4 Faraday. And 4 Faraday is 4 times 96500 coulombs. And since the question asks us to calculate the quantity of electricity that will be required to liberate 4 grams of oxygen gas during the electrolysis of acidulated water, there we all know that Q equals to IT, and we also know that M equals to ZQ. So, and since we know that the quantity that is responsible for this is 4 times 96500 coulombs, which gives 0, 0, 0, 2, 6, 2, 3, 8. So this is 386,000 coulombs. And since the question asks us to calculate the quantity of electricity that is involved, the quantity of electricity that is involved to give a diatomic gas, which is oxygen, which requires 4 moles, is 386,000 coulombs of electricity is required. Uses of electrolysis. What are the uses of electrolysis? 1, it is used in the extraction of metals, and that is done by when a compound of interest is copper sulfate. We can, when it ionizes to this, and by subjecting this one to what you have at the cathode, copper is deposited at the end. So by the process of electrolysis, we'll be able to extract this copper from this compound. That is one of the uses, extraction of metals. 2, purification of metals. We can also use electrolysis to purify metals. 3, electroplating of one metal by another. That is, by electroplating a particular metal which is vulnerable to corrosion can be replaced by another metal that is resistant to corrosion. That is the process of electroplating. Then 4, preparation of certain important compounds. So these are the 4 ways or 4 uses of electrolysis. Question designed for this topic. 1. The major function of a salt bridge in cell is to A. Smoothen the electron flow, B. To provide the electrolyte, C. To complete the electric circuit, D. To provide adequate driving force. 2. Electrolyte in dry Leclanche cell is A. Anhydrous zinc sulfate, B. Pasty manganese 4 oxide, C. Ammonium chloride paste, D. Muslin bag. 3. In the activity series of metals, metals higher up will serve as A. Cathode, B. Anode, C. Salt bridge, D. None of the above. 4. What is electrolysis? 5. Differentiate between electrochemical cell and electrolytic cell. Now, to question 1. The major function of a salt bridge. Salt bridge is introduced into cell of different compartments to smoothen the rate of flow of electron. So if what you have here is copper and what you have here is zinc 2+, in order to ensure before there can be easy flow of electron, the amount of zinc copper here must be equal to the amount of zinc here, and if that is to be ensured, a salt bridge must be connected such that little of the negatively charged comes to the, let's say, A compartment and B compartment. Little of this comes to this and little of this comes to this, so that at the end you have equal charges in both compartments. So the answer to question number 1 is A. To smoothen the electron flow. 2. Electrolyte in the dry Leclanche cell. There is no other electrolyte that is used in this cell other than ammonium chloride paste. Ammonium chloride paste. So the answer to question 2 is C, which is ammonium chloride paste. Number 3, in the activity series of metals, metals higher up will serve as, since it is established that cathode is negatively charged and anode is positively charged. In the activity series, those that are higher up, such as sodium, calcium, magnesium, we migrate to the cathode because of the different in charges, positive, negative. There will be attraction. So the metals higher up, which are the highly reactive metals, move or migrate towards the cathode. So the answer to question number 3 is cathode, which is A. Number 4, what is electrolysis? Electrolysis is the chemical decomposition of a compound that is brought about by passing direct current through the solution of the compound or the molten compound. Number 5, differentiate between electrochemical cell and electrolytic cell. The difference between electrochemical cell and electrolytic cell is that in the electrochemical cell, it is a device that converts chemical energy into electrical energy, while electrolytic cell is a device that converts electrical energy into chemical energy. That is the difference. Hydrocarbons. What are hydrocarbons? Hydrocarbons are organic compounds which comprise of carbon and hydrogen only. When defining hydrocarbon, the word only must be mentioned because hydrocarbon contains just two elements, carbon and hydrogen only. The structure of carbon depends on the constituent atom and the valency of carbon, which is 2 or 4. Hydrocarbon is an organic compound containing carbon and hydrogen only. Examples of hydrocarbon: we have ethane, which is C2H6. We can see that we have carbon and hydrogen here. Ethane, C2H4. So for every hydrocarbon, you only have carbon and hydrogen only. Homologous series. What is a homologous series? A homologous series is a family of organic compounds which follows a regular structural pattern in which each successive member differ in its molecular formula by a CH2 group. Characteristics of homologous series. Characteristics of homologous series are as follows. 1. All members share a general molecular formula, which means for all alkanes is CnH2n plus 2. So every alkane must have this general molecular formula. For every alkane, it will be CnH2n. For every alkyne, it will be CnH2n minus 2. So they follow a regular structural pattern, and they also